Okay, today is 10-1, day 2, exploring quadratic graphs. So again, we are looking at quadratic graphs, which we learned the lesson before. They create what we call parabolas, or the curved U-shaped graph. Example 3 wants you to compare the widths of parabolas. It says use the graphs below. Order the quadratic functions f of x minus 4x squared, f of x is equal to 1/4 x squared, and f of x equals x squared from widest to narrowest graphs. So if I look here, and I'm just looking at the picture for now, this is going to be our narrowest. The middle one here is the widest, and this one is in the middle. So it asked us to go from widest to narrowest, so it would be y equals 1/4 x squared. The middle would be x squared, and the narrowest is negative 4x squared. Okay, so it says here, then it wants us to fill in the blank. I'm going to have to scroll down just a little bit. It's going to make mine just a little bit harder to read. The larger the absolute value of a. So let's talk about our a's here. The first a is 1/4, and that was the widest. I don't have an a here, so my coefficient is 1. So in the middle, the a was 1, and over here, a was negative 4. But it wants us to look at the absolute values of them. So the absolute value of the widest, so we went widest to narrowest. The absolute value here is 1/4, then 1, and the absolute value of negative 4 is 4. So the larger the absolute value of a, the more narrow the graph becomes. If I look here, this one had the largest absolute value, and it was the narrowest one. And it says, why is this true? And I'm going to type this in, because otherwise you probably won't be able to read my work. When we look there, don't want it that big. You can think of it as being similar to the starting slope, where it was mx plus b. Well, we're looking at the a here in front of the x squared. The higher the absolute value of a, the faster the parabola goes up or down, depending on if it's going up or down, making it more narrow. So that absolute value is like looking at our beginning slope, where it's telling us it's going to start and it's going to get narrow, or it's going to go up really fast, so it's going to be more narrow than something that is a lesser of an absolute value. Okay, example number 4 here then has us graphing. Graph both y equals 2x squared and y equals 2x squared plus 3. So now they're adding a c on it, and we want to know how a c changes the graph of a parabola, which you might remember from a section that we looked at earlier, or some of you did an extension on it. So if I look here, when we graphed it, we said we had 2 steps. The first thing you needed to find was the axis of symmetry. The axis of symmetry was found by taking negative b over 2 times a. So my axis of symmetry here is x equals 0. I'm going to draw that line in. And then it is to use your table of values. I want to find my vertex. I know this one's going to open up since it's a positive a, so my vertex is going to be the bottom. The vertex always is on the axis of symmetry, so I know my x value is going to be 0. So when I plug that in there, 2 times 0 squared gives me 0. So my vertex on this first one is 0, 0. And then I need to get 2 other points. I'm going to use 1. So 2 times 1 squared gives me 2. So my next point is 1, 2. And finally, I'm going to try 2. So 2 times 2 squared gives me 8. So 2, 8. And then remember, to get your other side, this is the axis of symmetry, so you just count. There's 2 from the green line, so 1, 2 from the green line. 1 from the green line, 1 from the green line, and then you can draw in your parabola. And hopefully yours is looking a little bit better than mine. Now it wants us to graph that second quadratic function there. Our second quadratic function is y equals 2x squared plus 3. So basically all they did on this is add in a c. So we want to see basically how that changes the graph. So if we look here again, the axis of symmetry is negative b. I do not have a b because I do not have an x value. So again, my axis of symmetry is going to be x equals 0. So the axis of symmetries are the same. That means my vertex is also going to be on that same line. So if I do that, 2 times 0 squared plus 3, I get 0, 3. Well, my other vertex is at 0, 0. This one's at 0, 3. Now I'm going to try my 2 other points. I'm going to use 1. So 2 times 1 squared plus 3 gives me 5. And I'm going to try 2. 2 times 2 squared plus 3 gives me 11. So I get 1, 5. And I get 2, 11, which is just barely off the graph. Now remember, then we go the opposite direction. So 1, 2 over, 2 over, 1 over, 1 over. And then I'm going to draw in my parabola. Okay, so it asked me at the beginning, how are the two graphs different? The two graphs are different because y equals 2x squared plus 3 is moved 3 units up. So that c is telling me how I moved, and this was a positive 3, so I moved the graph of the basic parent function up 3. Okay, our example number 5 then is our real world problem solving for this section. Suppose you see an eagle flying over a canyon. The eagle is 30 feet above the level of the canyon's edge when it drops a stick from its claws. The force of gravity causes the stick to fall towards Earth. The function h equals negative 16t squared plus 30 gives the height of the stick h in feet after t seconds. Graph this quadratic function and describe a reasonable domain and range for the function and explain. Okay, so if I look here, basically they want us to graph this function. H equals negative 16t squared plus 30. Well, I want to write my x actually here is representing t, which is time in seconds, because the t is in the place of the x, and the h is in the place of the y, and that's representing height in feet. That way I know what my two axes are representing. Okay, now we go ahead and we need to find the axis of symmetry. So my axis of symmetry, I don't have a b, so b is 0, so anytime that happens, my axis of symmetry is always going to be x equals 0. So there is my axis of symmetry, and then I have to do my t-chart. I want to find my vertex, 0, and if I plug it in here, that would give me 30. I'm going to plug in 1, which would give me 14. And if I plug in 1.5, it gives me negative 5.7. Okay, then I have to figure out what I'm going to go by on my axis to get it to fit, because I have to be able to go up to 30. So I'm going to choose to go by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So 0, 30 would be there. It's negative, so I know this, a negative a, so I know this one's going to be opening down. My next one was at 114. Across the bottom, I'm going to go by half, so that's 0.5. That would be 1.52. And that's just to spread it out a little bit, so maybe it's a little bit easier to see. 114. And then I have 1.5, negative 5.7. Well, if I go down, there's 2, 4, 6, negative 5.7. I'm going to go somewhere in there. Okay, and then if I think about this, normally we'd get the other side. But it does not make sense for time to be negative or for height to be negative. So I'm only going to use this one side. And then once I have it drawn, the only part that would make sense for me to use then is the part that is actually in quadrant number 1. Right here. No other parts would make sense to use because I can't get height or time to be negative. Okay, it then asked, describe a reasonable domain. Remember, domain are your x values and range, which are your y values for the function. Okay, so my reasonable domain numbers are your x values. So we talked about how we can't go negative, so we'd start at 0. And if I look here, it crosses at what looks like about 1.5. So I would say 0 to 1.5 seconds. My range values, again, it's going to be 0. But the high point here was 30, and then we would go down to 0. 30 to 0 feet. So those are your acceptable functions. And the reason why is because both feet and time cannot be negative values. Go ahead and complete your quick checks, and then look at your schedule for your assignment that goes with this section.